Welcome to another video of Java Under the Hood about the collections framework ArrayList. In this demo I'll examine how an ArrayList behaves when returning an element using the get method and when replacing an element with the set method. These are the two methods that I'll discuss. So the get method returns an element at a specified position, and the set element replaces an element at a specified position with another specified element. The sample code. In the main method I start by creating an array list and filling it immediately with 10 elements. Next I'll obtain the element at position 8 using the get method and print a message on the screen. Then I'll change the element at the same position using the set method. Then I retrieve the element using the get again and print some messages at the screen. After executing this code, it will produce following output. So first I print out 10 elements, then element at position 8 is 290. This is the message after the first get. Element position, the constant is 8. Then I call a set, and the set actually changes at the same position the value to 291, but the set returns the value of the previous element. So after the set I retrieve the get, which will return the new value, and so I print out element at position. This is the new value, 91, and the previous element retrieved using the set is printed out as well. Okay, let's find out in the memory layout to see what happens when I execute these statements. I begin with the creation of the array object with 10 elements. So local variable NRS, which stands for numbers, is allocated in the stack frame, and then my ArrayList object is allocated on the heap. A size of 10, then a reference element data referring to the internal array default capacity of 10 elements, and each element is a reference variable to an integer wrapper object with the corresponding values to 10 until 300. And so if I print out the content, I will have my 10 elements. Now let's obtain the element at position 8, the 9th element, using the get statement. First, local variable lm that will hold the result is allocated in the stack frame, and then executing the get, we arrive in the ArrayList class of the GDK. Let's set up the stack frame for this method. This is an instance method call. The first element in the local variables is the this pointer referring to my ArrayList object, and the second element in the local variables array is the index, so we want the element at position 8, and a space is reserved for the return value. Looking at the implementation of get in the ArrayList class. First, an index out of bounds check is performed, after which a method call to element data within the same class is executed. As mentioned in the previous demo about this notation, so I have a method here, I have a method here. Now these are just code snippets that I've put together. Nested methods don't exist in Java, I know, but I found the syntax to display the sequence of method invocations convenient for demo purposes. So the call to element data, setting up the stack frame. So I have the this pointer, and then my index is passed along 8. Then the implementation, return element data square brackets index. Note the difference with the invocation of the method. Same name, but here we are using round brackets. So this is a method invocation, this is array indexing. So don't be confused with this notation. What are we returning? Well, this method is an instance method call. So every data member is implicitly preceded by the this dot notation. So let's follow this from the stack frame, this dot element data. So this refers to our ArrayList object. Data member element data refers to this internal array, and we want to index element with value index. Index in the stack frame is 8, so this is the element we are accessing. we are returning the content of element located at index 8, which represents a reference variable holding the address of integer wrapper object 290. So the value of 3090. I repeat, these are all fictional addresses. This address is thus assigned to the return value of the method. Before continuing, we are at the heart of the get method. The place to hold for a second and think about the performance of this method related to the amount of elements that ArrayList holds in the element data internal array, the big O notation. In the previous demos, where I analyzed the different add methods, we saw that most of them were ON or amortized O1. Here the get method returns array indexing, and that's it. Since the time to execute array indexing is independent of the amount of elements stored in the array, we can conclude that get is a O1 method. So independent of the amount of elements stored in the array, the get always performs equal time. Okay, continuing with the get, we leave the method. The return value is passed to the previous stack frame. And we clear the method of element data. And we're back at the stack frame of the get method. We leave this method as well, but at this stage we can't assign the return value to the lm integer of the main method. But the runtime still holds on to this integer wrapper object. We'll see why in just a second. First we clear the stack frame of the get methods, and we're back at main. What happens next? Well, examining the return value of get tells us that we're dealing with the reference to an integer wrapper object holding the value of 290. So on the right hand side of the assignment statement, we have something that is of type reference type to an integer. On the left hand side though, we have primitive type int, and those two can't be assigned directly. Now those two don't match, but there is an implicit conversion taking place. One last step must be performed before int lm holds the value of 290, namely by what is called unboxing. The runtime performs this by automatically invoking the int value method of the integer class. I explicitly note it here, but in your code it can be omitted since, like I just said, it is called automatically. Okay, let's set up the stack frame for this int value method. So it's an instance method, so I have a this pointer, and the this pointer is the actual integer wrapper objects. No parameters. What does this method do? Return value. And what is value? It's a 290 value that is wrapped into that integer wrapper object. And this is what we're going to return. So our return value holds the value of 290. Now we can leave the method, assign the return value of the method to the lm local variable declared in the main. It is this assignment that is performed now. And we can clear the method, and we're back at main. And there we have our 290 integer lm returned by the get method. If we were to print out a little message, we would see that element at position 8 is 290. What about replacing an element? Well, let's set the value of element at position 8 to a value of 291. I just extend the stack frame a little bit for local variable previous, because that is what the set method returns, the value of the previous element at that position. So we expect a value of 290 when we come back from a call to set. Now set adds objects, not integer constants. So out of 291, using boxing, an integer wrapper object is first created. That is explained in a previous demo. Then the actual set method of the ArrayList class is called. Let's set up the stack frame. So we have the this pointer, we have index 8, and we have the new element, so referring to 3191 fictional address. The return value of the set method represents the current value of the element at position index, so 8, before it is replaced. The current element is an address, So the set method, in other words, returns the previous or old value. And thus, after performing an index out of bounds check, the set method retrieves this previous value first, or old value, by invoking what I've explained earlier, namely the invocation of method element data, which is used as well in the get method. So local variable old value, and the return value is the address of the object. After that, the core of this method, setting the element, replacing the element, the actual assignment of element at position 8. So let's see with the stack frame what is happening here. Element is here my reference to my new integer wrapper object. Element data, this is my data member, so this dot element data refers to this internal array. Index is 8, so this element will be overridden by element. So this value will be overridden, and we now refer to the new object. I just set it out in blue so it stands out more. And that's it. Then the return value is set. That is a return value of the old value. So the return value is set. Let's pause for a while and examine the performance of this method using big O notation. As with the get method, array indexing is performed. We saw with get that array indexing is constant time, or O1. Set uses array indexing as well, so set is an O1 method as well. That's it for set. We leave the method, clear the stack frame, and after an unboxing operation, the return value of previous is 290. But note as well, the array at position 8 is referencing our new integer wrapper object holding the value of 291. Good. So to resume, get is used to return an element, set is used to replace an element. Since both use array indexing, both are O1 methods. Thank you for watching, for liking my video or subscribing to my channel. Bye bye.